My name is Mark. This is Elango.
Hey.
And we're both engineers at Box, and we'll be talking about real-time threat detection with Apache Beam. So just to give you a quick overview of what we'll be speaking about. So first we'll go over the current threat landscape. How does ransomware actually impact the world? An architecture overview. So how did we actually build this pipeline? And then we'll follow that up with the challenges we faced while building the pipeline and how we solved them. And lastly, we'll go over how do we orchestrate data flow at Box to allow developers to build data flow pipelines. So before we get started, can I get a show of hands? How many of you have heard of ransomware? So I'm seeing like everyone knows about it, but to me, I personally thought it wasn't really that big of an issue. You just hear about it. It doesn't really happen. But we're a content management platform. Our customers constantly face new threats, and ransomware is very real, or a very real threat. So just how bad is it? We polled our customers, we did some research, and ransomware has remained on the #1 priority for our customers to help mitigate. So through our research, we found there's been a 37% increase in the presence of ransomware in observed breaches. A 115K median ransom paid for ransomware attacks, which could be very damaging for companies. And lastly, a very interesting stat, 50% of leaders thought they were prepared for attacks, but they still fell victim. So what does getting hit with a ransomware attack actually look like? Well, first off, you'll face a huge disruption of business, depending on how deep it's gone. Maybe your service will go down, lose some customers due to losing their data, or maybe you can't operate due to locked up files. And as such, your data is compromised. We don't really, you won't know who's looked at it, where it's been. So it's a very big issue for companies with security policies. And lastly, the actual ransom you pay is very expensive, and you don't even know if you're going to get your data back. And so you could be paying into a void and just getting your money stolen. So at Box, we really want to ensure that our customers feel safe with their data on our platform. So bringing latency down on threat detection is a very important key to managing content. So we'll just hop right into the actual architecture of the pipeline. So this is a broad overview, but we essentially read our enterprise events from PubSub, which is managed by our data platform team, which then feeds into our pipeline and outputs alerts to PubSub once again. We store our model in GCS, and this is an in-house built model trained offline. We do eventually plan on experimenting with other like live updating models, so using TimesFN or in-house transformer-based models using Vertex AI. So to go over the actual data flow pipeline and how we use Beam, we start off with reading our events in, obviously, and then we'll do a bunch of pre-filtering, make sure that we're only really getting the events that are important to our model. We'll also filter out some extension data, so make sure that we're only processing relevant extensions, excluding things that would obviously be might be negative, not actually an issue. So after we do our filtering in advance, then we do our windowing. So we start with a minute fixed window, which then goes into a 15-minute sliding window. The reason for this is it reduces the worker burden, so we can run less inferences. And then from this, we have our model input, and then we run our inference, which is made super easy with Beam. And lastly, we don't want to spam our customers with alerts for the whole attack. We only really want the first instance of realizing that it's an attack. So we deduplicate our alerts, make sure that we only output the first one, assuming unless the attack is going on for more than a day. But we do this through some state processing. So what are the challenges we faced while building this? Well, first off, how do we actually test on a live pipeline? How do we make sure that the pipeline is always up? How can we push changes without taking it down and no loss of data? How do we scale to production volume? We're dealing with millions of events daily, so we have roughly 10 to 15K messages per second that we need to process. So making sure that everything in our pipeline is efficient is very important. And lastly, as I just mentioned, how do we deal with handling alerts properly so that we aren't spamming our customers? Since attacks could go over hours, when it's first detected is what we're really looking for. So to answer the question on how we actually test, for changes deployed, we've set up a pipeline to ensure that changes are validated before releasing. So you can see here, we start with our unit tests. So we're just validating our understanding of Beam, so making sure that our windowing techniques are doing exactly what we expect. And similarly, like caching and all our modules are functioning, transforming data exactly what we want it to be. So once we finish those unit tests, then we move to an integration test. So our box security team actually performed a live attack, and we were able to store the raw events from this attack, which we then use as our golden data set. So we send these, in our integration test, we send these snapshotted events to a live test pipeline, which then, only then when it outputs the expected alerts, will move forward. So from here, we update the artifact store, update dev, make sure that the pipeline is able to launch and process as we expect. And then lastly, before pushing to prod, we open a PR through our build process and trigger an in-place update, so we have 0 downtime and 0 data lost. So how do we make sure the pipeline is actually working at all times? Like ransomware attacks are not very common, so you won't really be getting true inferences very often. So we've actually obtained the source code to the attack that I just mentioned that the box security team did, and we were able to set this up on a job that rotates through a bunch of different attack scripts that have like slight variations in them, and that is constantly feeding into our event stream. So that's one way of real-time testing, and we also wrote a custom simulation that's more lightweight and essentially is just a mass file renamer. So we have alerts constantly outputting, making sure that our downstream dependencies are all working, and then we finally write our alerts to PubSub. You can see here we also write to BigQuery. That's more of a debugging / future-looking store. So we do plan on eventually using a live model. So we'll use this as a feature store, and also we can see raw model inputs corresponding to their outputs to make sure that our model is inferring as we expect. So one of the challenges we faced while building this was we want to use auxiliary data to be able to do some extra filtering, but we can't really call BigQuery for every bundle, every element. It's very expensive. So like our workers would face a huge amount of burden to have to do that for every element or bundle. So we've used Beam's shared cache implementation. This way, our workers only need to call BigQuery once based on a stilled timer. So we have that set to 24 hours, so that we make sure that we're not calling BigQuery too often. The auxiliary data isn't super time sensitive, so just making sure that we're reading the latest is important, but it doesn't need to be instant. Hence why we use a timer for this. So we've also used the state timer from Beam to deduplicate our alerts. So we get our incoming alerts from our model, and then we generate a hash unique to it, to each alert, or to each attack. And our dedupe logic is essentially we will check, have we seen this alert hash in the last 24 hours? If we have, we'll skip publishing. If we haven't, we'll add it to the state cache, and then we'll publish the alert to PubSub. So as I said, we have 10 to 15,000 messages per second, so production readiness is very important here. We've used Dataflow auto-scaling to minimize compute. That's been super easy to enable. It's just a setting. We're also able to use data sampling through Dataflow, which has been very helpful in observing transforms throughout the pipeline, making sure that intermediate transforms are all transforming as we want them to. Also, we have built-in fault tolerance through Dataflow, so we have zone failover, worker failures are handled. We don't have any, we don't have as many issues with, we don't have to manually deal with these issues. So, and lastly, efficient memory management. So as I mentioned, we use our shared cache. We also used the minute fixed windows into 15-minute sliding to reduce the worker RAM burden. So what does it actually look like in effect? Right here you can see this was the box security attack. You can see this was over a few hours. Pardon for the axes, the time axis, but this is 3 consecutive attacks, and you can see our model starts off with a low confidence and then slowly increases as the attack progresses. And then we reach a max value, and then once the attack ends, it'll slowly taper off. The image on the right is, just an expanded version of the first attack, just so you can see the behavior of the model as the attack goes on.
Hey, so I'm from the data platform team at Box. So we are tasked with like the orchestration of the Dataflow jobs. So we expose a config-based model to our tenants so that like they can focus their efforts on writing the actual job logic, and the orchestration of the job is like abstracted away from them. And we expose config like, so the tenants who want to like kick off a Dataflow job have to provide configs like template.json, worker images, and their actual job jar logic, the file path to that. And yeah, we also have a context, which is like, which has all the IO connectors written onto it. So they also have to provide like a path to the job jar version, to the context jar version. And they can optionally provide endpoints of the internal box services that they hope to hit with their Dataflow jobs. So yeah, this is how like the Dataflow orchestration is done. So we use Dataflow flex templates at Box. So Dataflow service kicks off like an initial VM instance of the launcher, and then it pulls in the template.json file that the tenant provided, and it knows where to get the launcher image from that. And then like it also pulls in the context jar, and it pulls in the job jar, which has the custom job logic that they wrote in. And once the launcher instances are kicked off, it pulls in the worker image path that the tenant provided, and it kicks off the workers. So with this worker image, worker image has all these like Beam related packages installed in them. And optionally on top of that, we can also add specific packages for the Dataflow job that you need pulled in. So this can also be done within like the job jar logic, but the problem with that is like every time the worker initializes, it has to pull in those dependencies, and it might cause the initialization to take a long time. So we just bake it into the worker image so that it's much more faster. And so yeah, the job jar like interacts with the context jar to hit our like source and sinks. So the context jar has these input-output connectors written onto them. So tenants actually just have to provide like any input, like it can be a PubSub, BigQuery, and any output, and it knows like which input-output connector to use. The context is like picks up the appropriate IO connectors. So yeah, once the worker map reduce task is done. The launcher basically cleans up everything, and the worker writes to the sink. So yeah, that's pretty much it.